if tangent theta is equal to 24 over 10, and theta is between 0 and pi over 2, then find sine, cosine, and secant of these angles. So first thing I always usually do is when I want to find sine, cosine, and secant is I try to draw a triangle. All of the trig identities are all coming from a triangle. So I try to look at the information that I'm given and see, can I draw a triangle? So I know that tangent is equal to opposite over adjacent, the opposite side over adjacent side of a right triangle. So I know I can draw a triangle. Let's like this. We can call this side theta, and then this side my 24 side, and that side my 10 side. Oh, wait. No, then that would be theta because the opposite is 24. Okay. So our triangle might look like this. Now, even better, try to draw the triangle on the unit circle. So let's even go one step harder than that. Because it's in this angle is between 0 and pi over 2. Pi over 2 is 90 degrees, because if you plug in pi for 180 for pi, then that is just 9 degrees. So it just means it's in the first quadrant there. So it's best if I can draw an angle that have sides. So that if it's on the unit circle, it's y over x. So the y value being a lot taller than the x value. So like this. Here we go. So this side being 24 and this side being 10. Now, to find all the other ratios, all I have to do is I have to find that missing side of the triangle, which is this r side. And then I just have to remember that, that sine, what sine is equal to y over r, cosine is x over r, and secant is r over x. Okay, so y over r, cosine x over r, and secant r over x. There we go. Okay, so that means I need to find this radius. If all three of these ratios require the radius. So I can just use Pythagorean theorem. And before I move any further, one thing that I could have done in this problem to make my calculations a little bit easier is noticing that I can reduce that fraction, 24 over 10. I can divide both sides by 2. So if I do that, I get a triangle that's similar to the original triangle, which means all my trig functions are going to be the same, but my calculations are going to be easier. Because this 12 over 5, because I divide by 2, the numerator by 2 is 12, divided by the denominator by 2 is 5. 12 over 5 is the same same value as 24 over 10. Two fractions that one is just the reduced form of the other, so they have the exact same value. So this triangle also has a tangent equivalent to 24 over 10. So it's fine if I use this triangle to find the missing side and find the other ratios. So if you would have originally kept the 24 and 10 and done all your calculations then your answers would have reduced to the same answers that I'm going to be getting right now. So this is just making things simpler. Okay, so I use Pythagorean theorem to find the r. So that's a squared plus b squared equals c squared. I plug in for A, the 25, the 5, I mean, and the B is 12, and then C. So I get 25 plus 144, which equals C squared. So that's 169 C squared. The square root of both sides, I get 13. So that means that this R side is 13. So sine is just 12 over 13. And cosine is 5 over 13. And secant is just a flip of that. So it's 13 over 5. And there we go. There's our three ratios. Now, if they would have said this is another quadrant, you're in. Because between 0 and 2 pi is in, it's in this region, right, of the coordinate plane. So if they would have said between pi over 2 and pi, then you would have been, in this quadrant, which is quadrant 2, And so sometimes I just do all my calculations, just focus on the triangle. And then I think about, okay, well, sine or cosine is going to be negative in a certain quadrant, and then I would have to correct my the signs and everything. But if for any angles or triangles, any angle in the first quadrant, it would form a triangle in that first quadrant, all your trig functions are going to be positive. So we know these answers are positive. All right, have a great day. Bye.